Hi, everybody. Welcome back to the Feynman Technique. So today we are going to develop the solution to kind of a weird infinite sum. This is the sum right here. It's just the sum going from 1 to infinity of negative 1 to the n times sine of n over n. And this sum has come up a couple of times when I've been trying to solve some integrals. So I thought I would use the formula that I showed the derivation for in my last video. I will link to it in the description to figure out what this sum is equal to. So what we're going to do is we're going to start with the formula that we derived in the last video. And that's this. And so in a previous video, we found the following representation for a function of x on the interval negative pi to pi. Okay, and that's this equation right here. Again, I'll link to the description where I showed that. This is a Fourier series. This is like the one of the forms of the Fourier series formula. But we're going to use that to find this sum. Okay, so the first thing we're going to do is we're going to let f of x equal x. So we're just replacing f of x with x anywhere we see it. All right, so that's the form, that's what it becomes after you do that. All right, and then we'll note that this integral right here, this is simply 0. This is an odd function integrated over a symmetric integral, so it goes to 0. As does this one. This is also an odd function over a symmetric integral, so it goes to 0. That one's right here. And then finally, for the remaining integral, we will get this. Now, I'm not going to show how that happens, and you have to take into consideration that our n's are all positive integers. So you would expect to find a cosine, some sort of cosine in the answer when you evaluated that. But if you take into account the fact that n is always going to be a positive integer, it simplifies to this. And I'm not going to show that in this video. If you want to do it yourself, go ahead, but just keep in mind that n is always a positive integer. All right, so we're going to use that this integral is equal to this. So now we're going to substitute those values back into this formula, and our formula simplifies a lot. We just end up with x being equal to this. And go ahead and plug that into a graphing calculator, and you will find that that this thing it equals x on the interval negative pi to pi. And that simplifies to this. So finally, we just have some value x being equal to that. And you can see that this is almost equal to this is almost the sum we want. What we'll do is we'll let x equal 1, because if this equality holds on the interval x is equal to negative pi to pi, then it will hold for x is equal to 1 as well. All right, so we just set x equal to 1. All right, and what we get is this. Setting x equal to 1 gives us this, and that will simplify to this. All we do is we take 1 away from this index right here and introduce a negative sign and then divide by 2. So we find that the sum as n goes from 1 to infinity of negative 1 to the n times sine of n over n evaluates nicely to negative 1/2. All right, guys, hopefully I'll be using that in a future video where I will actually start doing some Feynman integration today, or when I will actually start doing some Feynman integration. But anyway, for now, I hope you enjoyed that, and we'll see you next time.